In this video, we are going to filter a point cloud down to ground in CloudCompare, and we will compare that to some check shots we took with GPS. When I open an LAS or LAZ file in CloudCompare, I always click Apply All and Yes to All. And this allows CloudCompare to bring this data in, and it allows CloudCompare to align its coordinate system with what is in the point cloud. If you want to download CloudCompare, you'll just search for it, click Downloads, and download the CloudCompare Unified for Windows. And CloudCompare also works on Mac OS or Apple products. CloudCompare is free and open source. Okay, once your point cloud has been brought in, you may not see any information at first. In this left-hand navigation window, you can go in here and instead of RGB, I can show the color of the scalar field, which is the intensity, and I can tell CloudCompare that I'm only interested in intensities of a certain range. And when I do that, it will show me the intensity return of the point cloud. The next thing I'll do is quickly filter the point cloud of any really big outliers. So I'm going to bring this top, I've got a side view going, and I'm going to bring this top down until I'm starting to cut off my trees. A little bit difficult because my computer is running slow with the video recording. That looks pretty good. And then I come over here and I slice it and I export the current selection as a new slice. So I click that and then I click X to be done with the slicing tool. We give it a second. This is now the section that I cut out, and I've also turned off the original or remaining section right here. So this has those outlier points and I've turned it off. Now that I have the remaining area, I can go to Edit, Colors, Height Ramp, and I can do it based on the elevation. And I will now have a colorized point cloud based on elevation. So we can see some canopy here that we want to filter out. To filter for ground, I come up here to Plugins, ensuring that I have selected the section that I want, and I click CSF Filter. Now, when I did this example, I did not do any special settings. I just selected flat. You can go in here and you can adjust the cloth resolution, how many times it iterates, and some threshold information to manually modify the results or to influence the results in a way if you were in a job with a very difficult terrain. The other thing you can do is you can cut up sections like I showed, but horizontally, and you can process a section of creek or a section of flat, bare earth in different ways. But I'm going to go ahead and just let it run with its defaults. And this cloth simulation filter is sort of draping a cloth along the bottommost points of your point cloud. And then it is looking at how high points come off of that point cloud in any given section to try and filter for ground. Once this completes running, it will organize your data into ground points and off-ground points. If you want to, you can redo your height ramping for just the ground points on elevation, and that can give you some idea of what you're looking at. When I want to bring in a text file, I'll come over here to Open, and I'm going to bring in a text file with point description northing easting elevation. Oh, I think it's labeled incorrectly. I think this is point northing easting elevation. That's right. So I combined the point number and description here. And the LAS format is easting northing height. So my text files are northing easting height, and I tell it Y, X, Z. And then I apply all, and I say yes to all. And now my ground shots are showing up. And because I combined the point number and description, I am able to see them well labeled here. When I want to compare the ground shots to the ground points, I will select them both, and I'll come up here to Tools, Distances, Cloud to Cloud Distance, and compared will be my ground points, compared will be my GPS shots, reference will be my filtered ground points. And I'll click OK. And I will select to split the X, Y, and Z components so that we'll be able to look at only the nearest Z elevation in our comparison. I click Compute, and then I click OK. Now I can click on the ground shots themselves, highlighting just the GPS shots. I can ensure that the scalar field visibility is turned on. I can then scroll down and I can turn on the absolute distances in the Z direction. Turning on this graph over here will actually show me a histogram of where most of the points fall, and it will also show me the maximum negative and positive values for these Z distances. Finally, with this highlighted, the GPS shots themselves, and with the Z scalar field enabled, I can click over here on the Show Histogram. I can look at the histogram much like is displayed over here, showing that I'm not busting by much more than 2/10 on any of these values. When I want to export these ground points as an LAS or even an ASCII file, I can highlight my ground points, click File, Save. And save as the LAS file type or LAZ, keeping the scale, using the original offsets. I'm not going to change the default settings. If I turn off these ground points, and then I open up this folder that contains what we just exported, and I click Apply All and Yes to All in CloudCompare, we're now bringing in the exported LAS of just ground points, and we can see those showing up here. So I can turn that back on. Can also turn on the original vegetation, and you can see that it all lines up.